All right, welcome back. So I've got an initial value problem here. I'm trying to find an equation for y given the derivative, and I'm given a point. So we've seen initial value problems before. Let's just dive right in. First thing I'm going to do is separate the variables. This is x natural log of x dx on the right. I'm going to integrate both sides. And immediately I see, aha, look, it's a parts problem. It's two functions multiplied together, and I don't see a substitution there, so I can't go to substitution. So I'm going to, what am I going to do? Well, I could either make u equal to x and dv equal to natural log of x dx, but I see a problem there. The antiderivative of natural log, a bit more complicated. I'm going to switch. I'm going to say that u is equal to natural log of x and dv is equal to x dx. Now, this is nice and easy because that's just 1 over x dx, and this just means that v is equal to 1/2 x squared. And so my parts gives me y is equal to, now, u dv 1/2 x squared natural log of x minus the integral of v du. So that's 1/2 x squared times 1 over x. So that's just 1/2 x dx. And that means that my next line can be 1/2 x squared natural log of x minus the antiderivative of 1/2 x. Well, that's got to be an x squared. And that means I need a 1/4 in front of that plus a constant. Now, initial value problem, y of 1 equals -1, and so I can calculate the constant by plugging in -1 equals 1/2, 1 squared, natural log of 1 minus 1/4, 1 squared, plus c. Natural log of 1, of course, is 0. I know that because it's the x-intercept of the natural log graph. And so I'm going to add 1/4 to both sides, and I get that the constant is equal to -3/4. So now I can just write the equation y equals 1/2 x squared natural log of x minus 1/4 x squared minus 3/4. And you can see, again, the point of this parts is that I was able to find the antiderivative of a pretty somewhat complicated equation, definitely a complicated function, but I was able to work it through using parts. So let's jump to a problem and let's see what happens here. We're going to go e to the x cosine of x dx. I'm going to let u equal e to the x, and I'm going to let dv equal cosine of x dx. Now, what if I had done it backwards? I'll leave that to you to switch them around and see what happens. But in the meanwhile, I want to stick with this because I want to show you something interesting. Antiderivative of cosine is sine. And so integration by parts says uv, e to the x sine of x, minus the integral of v du, e to the x sine of x dx. Okay, well, it looks to me like I need another parts. We'll make u equal e to the x. Du is the same. We'll make dv equal to sine of x dx, which means that v is negative cosine of x. And so now we have that the integral of e to the x cosine x dx is equal to e to the x sine of x minus, don't forget your parentheses, uv, that's negative e to the x cosine x, minus integral of v du, so that's minus e to the x cosine x dx, keeping track of all of our minuses, this becomes e to the x sine x plus e to the x cosine x minus the integral of e to the x cosine x dx. And in case you'd lost track there, we had a minus and a minus and a minus, so 3 of them. And of course, this all equals the integral of e to the x cosine x dx. Now, you might be saying to yourself right now, self, this doesn't help. I still have another integral, but then you might notice that it's the same as the first one. So if I add this to both sides, I get that twice the original integral is equal to e to the x. I'm going to go ahead and factor the e to the x just because I can, mostly so I only have to write it once. And therefore, I can just divide that by 2, and boom, I have the answer. So what caused this to happen? Well, what causes this, what makes it interesting, is the fact that this is cyclic and that doesn't change. So what you're looking for on this repeated generally is, do I see one where something is going to cycle back and forth? My dv is going to go back and forth between cosine, sine, and the other thing's not changing, which means if I just do it a few times, I'm going to get to where I have the same thing again eventually, at which point I move it over, boom, I've got my answer. All right. I will stop there. We'll be back with another couple examples. Thanks for watching. Hope you learned something.